Okay, yeah. Hello and welcome, everyone. I'm very happy to welcome you all here in the name of RIAT, the Research Institute for Arts and Technology. And we are happy to have the Ethereum meetup here today in the Museumsquartier. Also, a little bit of a context. RIAT is an independent research institute, and we are organizing various crypto-related events since quite some years, actually. And also we are publishing in this regard. So, for example, just to give you a bit of a context, in the Handbook of Digital Currency, we have been writing a chapter also 2 years ago, or actually 3 years ago, in pointing out specific technologies which will be relevant today in end of 2016 and of 2017. And we are basically focusing on crypto economics and the blockchain, also with the background of art, which might sound a little bit strange or maybe a little bit interesting. But maybe to give you a bit of a context, so RIAT is an international network and research cluster. We have our location here in Vienna, and we are basically doing developer-centered research and development, research-based education on the example of Ethereum workshops and other workshops in this context, which are not only blockchain related, but also foster crypto literacy. So we do also research-based education. I will briefly also explain that. And we do applied research with universities and companies. So yeah, feel also free to talk with us. There's a lot of my colleagues also around, and I'm also there later. And maybe just a few notes on the actual RIAT space, because originally we wanted to do this presentation today at the RIAT space. We are currently reconstructing the space, and we are very happy to welcome you again in approximately, I would say, August, where we will actually continue all the crypto-related events, all the crypto literacy events, and all the blockchain-related workshops. So until now we had over 40 crypto-related events so far happening in the space, which we are having for approximately 11 months, and it will continue. So since we have a contract for 10 years, we'll be there for a long time. And this is how the space looks in case, I think most of the people were there already, but this is the space how it looks empty. And here you see one of the Ethereum events where there was Vitalik Buterin explaining a few details on the Ethereum roadmap, which was an event that happened earlier this year. And also the Doge meetup, where here you see the celebration of the Doge coin with the Doge actual cake that is always like celebratory cut in this context. And we also have the Satoshi Nakamoto residency, which is a residency which is located here in the Museumsquartier Vienna, which is hosting researchers and crypto-related people, mostly people on the intersection between art and technology, but also crypto researchers, developers, which can work here and stay here for 1 month. They get a funded residency where they have a space within the Museumsquartier, and they also get a stipend to work with us on various projects, which are mostly related to the meetups or specifically with the research topics of our institute. So we are mainly supported by individuals and also companies. And we are also happy to announce today that we are planning what we call Academy for Crypto Literacy, which will start after this summer. So in case you're interested in getting more information on this and getting early in, then you can subscribe on our website, basically RIAT.at, or on our Facebook page. So you can get early information on what we are doing, and there will be various workshops and also an academy starting. So currently we are also doing already a lot of workshops. Mostly Ralph Pickler, my colleague here, is organizing the Ethereum workshops, but we will extend this also to different currencies, different approaches, and also to more generic blockchain education, which is of course developer-centered, but we are currently also testing the scope that we want to actually reach with this. So I'm also now happy to call Ralph on the stage, and thank you very much for listening, and have a nice evening today, which will be actually presented by Microsoft also in this context.
Okay, then welcome from my side. My name is Ralph. I am the organizer of the Ethereum Vienna meetup group. Since we have received a lot of new members since the last few months, I thought it might be good to say a few words about our group. So our group was founded in early 2014, so we are quite old by now. I think we're one of the oldest Ethereum meetup group in the world. And we have grown a lot, especially this year. We are very close to getting 1,000 members now. We're going to We're probably going to hit it in July or August, but yeah, it's a lot of members. And over the last 3.5 years, we did a total of 44 events, so this is our 44th event already. And what do? We do meetups. At those meetups, we basically make introductions to Ethereum. If you don't know so much about it, basically we have such an intro presentation. What is it? Why do we need it? How does it work? And then we also do many technical presentations about specific parts of the Ethereum technology or applications that are built on top of it. And sometimes we also have startup presentations, most of the time internationally, because we don't have so many local crypto startups, but luckily a lot of startups stop by in Vienna sometimes, and then they also present at our meetups. Then we also do workshops. So since early 2016, we've been doing developer workshops somewhat regular. What are we doing here? Basically introductions to smart contract development. If you want to know how Solidity works, how to develop smart contracts, we do regularly those introduction workshops. And then we also have more advanced workshops that build on top of the introduction ones. Yeah. That's already everything. Okay. All the information about all our events you can find at our meetup page, which you should already know by now. Also, all our slides from every presentation, as well as all the materials from our workshops, are available on GitHub. So our GitHub account is Ethereum-Vienna-Meetup. There you can find all the resources. Yeah, and that's it from my part. And let's get to Microsoft.
Just a second, I have to set up.
Yeah.
Now it's starting. Until it has started, I want to welcome you all. Thank you for being here. It is a real honor to get the stage from the Ethereum meetup and the Ethereum community to present Microsoft's engagement in the blockchain space. I wanted to start with a video. But then first I will introduce myself and my colleague who flew in from France, Paris. So it's Thomas Conté. He is in the TED team and empowering customers really to get the most of what we have. So my name is Johannes Zessin. I'm working here in the Microsoft in the subsidiary in Austria. So we are based in Vienna, and I'm building basically Azure solutions. So I'm in the pre-sales, and I'm more or less the first technical touch point when it is about Azure and about building architectures, proof of concepts, and so on. And unbelievable. Sorry. I'm back in a second. It looks good. It did the same again. Okay, now it looks good. There we go. Geht der Sound?
Our mission is to empower every person and every organization on the planet to achieve more. Technology can shape growth. Help us be more agile. We can use technology to change, disrupt the landscape of the industries that we participate in. Building technology so that others can build technology and make things happen. Our success is not dependent on our products. It's dependent on the success that our customers, our partners have with our products. It's really not about our ambitions, but it's the application of our ambitions so that we can deliver digital transformation. I want you to envision what difference can you make to shape the world.
So, why I showed the video is, okay. So why I showed the video is that, of course, it is a marketing video, as you saw, of course, but it is actually true what is shown in there. So I joined the company 1 year ago. I had a very different opinion about the company, and when I joined the company, I realized that a lot is changing. So I was also in this open source stuff, and I thought, wow, Microsoft is really bad, and they're fighting everything. And the point is that it really changed. It changed with Satya. It changed that we open up, that we collaborate, and that we especially focus on the needs of our customer, on their requirements, and build our products around that. And basically, to finally, in what our mission is and what he says, and again, is to empower and to enable that the customer gets more successful. Because our products at the moment is not about we just sell some licenses anymore. We're talking about Azure, we are talking about cloud solutions, and we only are successful when the customer uses our product. So we have to find ways that they use our product. That changes the way we interact with customers, of course, a lot. So when we started with this project, it wasn't a project, it was just an idea that we present Microsoft's engagement in the blockchain space at the Ethereum community. And we thought maybe 30 or 50 people, and that was also the context. We organized everything around. Then the limit of participants has been removed, and now we had like 190 people, what led to this nice location and the food out there and everything. And yeah, it is on the one side, it's of course great that there are now so many people, and thank you all for being here and spending your time, especially in the evening. On the other side, it makes it a little bit more difficult, because at the beginning we really wanted to present a very technical presentation. Really, what is Microsoft offering and how can you apply it? Now we adjusted it a little bit, but it still will be technologically. So, and what is also important to know is that we assume that you have a certain basic understanding of blockchain. We won't introduce blockchain, and we are not talking about how we can apply blockchain. It will be, of course, and if we present an example, you will see that you can use it for a certain use case, but we won't go through different use cases. It is really about what is Microsoft doing, what is our strategy, and what are we offering at the moment, and what are we going to offer in the future. So when we talk about the agenda will look like as follows. First, I will introduce a very short introduction to Microsoft Austria. Then I will introduce the Microsoft Cloud Platform Azure, as it is really important to understand the platform everything is running on, otherwise you won't understand what the offerings actually are about. Then I will introduce the Microsoft's approach to blockchain, and then blockchain as a service. And then Thomas will go on and will introduce Ethereum Enterprise Alliance, and then also will be really technical about blockchain fabric. You will then understand what it is, and Cryptlets. Yeah, that's the agenda so far. So let's get started with Microsoft Austria. One thing maybe important to mention. We decided that we do the Q&A at the very end. So we have a certain time limitation restrictions, and therefore please note your questions, and we will answer them at the end. Before the networking part, we also have planned some networking afterwards. Therefore, we have the food and the drinks out there. Nice. So, Microsoft Austria, was founded in 1991. Has at the moment over 300 employees. Is based in Vienna, in Meitling, am Europlatz 3, if somebody says something like that. Then we work together with over 5,500 partners alone in Austria. So it is important to understand that Microsoft is really a partner-driven company. So when you want to implement something, usually you do it with partners. It's of course also impossible with us, but usually it is with partners. So we work together with 5,500 partners all around Austria. And then the third point is this notion of new world of work. It is of course, it is a sales motion in a certain way. We want to combine technology with how people work and also change by doing so the way how people work, but at the same time we want to apply it to ourselves. So the idea is really that we have our office there in Meitling, and you can go there and you see what new world of work means. And I want to show you a second video in this context. This video is really good in a way that it shows how our office looks like, but also how we work. For instance, if I have no fixed place where I work at. So I just have my phone, I have my laptop, and basically everywhere I have my phone and my laptop is my workplace, and I have to decide myself if when I work and I don't work. That's great for me if you like freedom, but it also comes with a lot of responsibility, because of course you have to separate private life and business. that was our office, so you have a quite good impression now how it looks like. This with the ducks is really true. We like producing masses of ducks in our garden. So, and if you want to work at Microsoft, here's a person we can directly get contact to. It's Gosha, he's a really nice person. She's also very friendly, so you won't get an email like, don't talk to me. You can really contact her. You see her email address there. You can also contact her via LinkedIn and just tell her why you want to work at Microsoft. We're always looking for people for different streams, for marketing, for sales, and also, of course, technical people. So far, the introduction. So, let's get started with Azure. As I said before, I want to introduce Azure as if you don't understand the platform it is running on, you won't understand the services. And before I start with that, my question to you, who of the persons here thinks that he can define cloud? Okay. Or, okay, say knows what cloud is. So if I, okay. Who of you, okay, that's not so many. We have to do some work. Who of you has heard of Azure or Azure? Okay, much more, that's good. And who of you has used Azure? Okay, there's a lot of space of improvement. Yeah, so maybe there were not many people who showed their hands, raised their hands when I asked what is cloud. So maybe just a very quick definition. There are different, I really like this one. So basically what is cloud about? Cloud is about the ubiquitous on-demand access to a shared pool of configurable IT resources. But what it basically means is you have somewhere running a service and you connect to it and you just use it. You don't take care of the hardware, you don't install it, you just use it. And that's really powerful, because if you think about how it works at the moment in companies. So in companies I worked before, it was like you need something, you need a VM spun up, you need it, and it takes like weeks until you have this virtual machine running. Because you have to go through a long process, you need someone who goes to the on-premise environment, maybe has to install something, it all has to be checked and so on, it takes ages. And with cloud, you just have the service running there, and you just click a button, put in some data, and what do you have? You have the VM running. It makes life much more easy. There are different cloud types. It is public, private, and hybrid. Public means, that's probably what most of you know, it is provided by a third-party provider, and basically everybody can go there, can log in, and provide some information and then use the services that are provided. In comparison to that, the private cloud is more controlled. It is still not, it is important not to confuse that. It is not something that is running on premise, it is still running somewhere else, but now you are in control of this environment. You define which services are running there, you define who has access to it. Very important difference. And the last one is hybrid. Hybrid means you combine different ways of deploying services. So it can be public-private, it can be what is usually the case with hybrid on-premise, so you have it on your premise, and public. Then there are different service types. On the very right, you see the on-premise world. In the on-premise world, you have to take care of everything. You need the hardware, you need the software, you need an administrator, you need to do everything yourself. And then if you enter the cloud world, it gets less and less. From infrastructure as a service to platform as a service to software as a service. On the left or on the right, you have infrastructure as a service. That is, you still don't take care of the hardware, you take care of everything that is above this virtualization layer. And you then use compute, you use storage, you use network. It is especially for administrators. If you go one step further, you go to platform as a service. Platform as a service provides you also the infrastructure. You have now all these services available, for instance, to build your applications, to build your solutions, and you don't take care of the hardware and you don't take care of the infrastructure usually. Of course, the boundaries are blurring, and the services are not always clear one or the other, but that is now the theoretical differentiation. And on the very right, probably what most of you know, software as a service, it's like Gmail, Office 365. You just go there, you log in, you use the service. You don't configure anything, you have the chance to, but basically you can just go there and use it. And then when we talk with customer, there are always the question why we should use cloud, and especially in the case of Austria, it is a tough game, but it's changing, luckily. There are different reasons why cloud makes sense. And cloud makes sense, first of all, it gives you flexibility. Flexibility in a way that you can use your services on demand. You just go there, you use it, you deprovision it if you don't use it, if you don't need it anymore. And you also, you pay as you go. That is, as long as you use the service, you pay for it. And if you don't use the service anymore, you don't pay for it anymore. Very simple. And then you have also all the services available you can use, you can integrate with another. Then you have this aspect of scalability. Really, if you ever have the chance to go to make a data center tour, do it, because it is just massive. You have an unbelievable amount of resources available to scale horizontally as well as vertically. That is, vertically means you just scale up a single machine, for instance, and horizontally means you deploy more machines and so get your power and more power. Then you have the aspect of resiliency, redundancy, and failover. For instance, when you take Azure, you have each data point is stored at least 3 times. Usually you can very easily configure ways where you can automatically fail over. So if you have something like a SQL database, you can, with some clicks, have you mirror it more or less to another location, maybe on the other side of the world. And it will automatically fail over as soon as it recognizes, aha, this one is not working anymore, or for storage accounts. And the last point, you have a broad set of services. So you just log in and you have, in the case of Azure, like over 200 services. So again, if you think about, if you do that in a company, think about, you have an idea and you want to realize this idea. You want to test it. How do you do that? You go through this day-long or week-long or month-long process to get anything, and then the idea is gone. It's not necessary anymore, or you don't need it anymore, or whatever. And here you just can go there. You have a massive amount of services that are cutting edge, that are up to date, and you can just use them. So and finally, what is Azure? So I introduced the cloud types and the service types, and Azure is the public cloud offering from Microsoft. And in this context, we offer platform as infrastructure as a service and platform as a service, and indirectly software as a service. So platform as infrastructure as a service is, as I said, compute, storage, network. Platform as a service are all the other services, from data analytics, machine learning, intelligence services, to app hosting, to media streaming, caching, whatever. And you can just deploy it and use it. And because I said indirectly software as a service, so if you use Office 365 or CRM, you use Azure more or less. Because, for instance, for authentication purposes, Active Directory is used. What is a tenant on? So you have a tenant on Azure providing the user information and credentials. So there are several key pillars. The first key pillar of, so if you see our Azure presentation, they maybe change a little bit. I think for this community here, the following 4 key pillars I will display are appropriate. So you have compliance and security. We know that to be successful in the cloud business, it is very essential to have trust. You have to trust us in a certain way, and we have to build trust to you. And we can only build trust if we have a secure platform. If we have a compliant platform you can use, and you can go to bed and can be secure, you can be safe, and you can sleep because you know my data is safe, my applications are safe, and so on. And so we invest over $1 billion per year in security, and furthermore we have security woven in from the very beginning in Azure. So it starts with the physical security, like how are the data centers secured, and goes on with how we secure what is running in Azure. For instance, which user has which user has which permissions when. For instance, if you think about you have an administrator in your company, how do you, probably he has all rights ever. So there is no mechanism to restrict that. And for instance, in our case, you can have a just-in-time administrator, and you can really define when should this administrator have which rights. And that, I don't know if you got aware of this issue with this hosting provider. I don't know where it was, in Denmark or something like that, where the administrator killed everything. So that happens if administrators have too much power. But they should have power, but yeah, should be restricted. So the second point is openness and flexibility. If you think about Microsoft, most people, on the one side, they have this impression, well, we have Windows and we have Office. That's the first impression most people have from Microsoft, and that's it. It's not true anymore, I want to say. It changed a lot. On the other side, people think, when it's about Microsoft, they just think about their own products. They think about proprietary products. And open source and Linux is like an enemy. And that really, really changed. Azure is, from the very beginning, designed to be an open platform. So we provide, of course, our Microsoft products. We provide proprietary products, but on the same time, we are an open platform to a lot of open source software, because we know it is very important to provide the software. Most servers are running on Linux. That's a fact. And we have, yeah, it's a fact. So what we provide on Azure is openness. That is, you can go there, for instance, if you spin up a virtual machine, you can choose not only like Windows Server, you also choose like Ubuntu or CentOS or whatever, many Linux derivatives. We have Docker, we have PHP, we have Hadoop, we have Redis, and so on. So it is really an open platform that should meet the requirements of everyone. That's the goal. Then diversity. Diversity, that is what I already mentioned with the broad set of services we provide. If you have an idea, there's I wouldn't say 100%, but 99% chance that you are able to realize it on Azure, because the tools are available there. And usually there are many ways you can realize what you want to realize. And the point is, what changed a lot for us is, in the time where we only sold Windows and Office, we just had this licensing business. So we, more or less, everybody was the same, we just sold licenses. And it changed a lot, because now every customer is an individual case. And with every customer, we have to build more or less individual solutions. So, and it shall be possible with Azure, and it is. And the last point is hyperscale cloud. What that means is you have massive resources, and these resources are distributed globally. So what massive means that you have 34 regions at the moment and 6 more announced. You have over 100 data centers in these regions, and you have more than 2 million physical servers, and it's increasing by thousands each day. So if you think about a company that should realize such resources, should have such resources, should realize such a high level of security, the question is, how can a company do that? It is very expensive, and it needs a lot of expertise. And if you use Azure, you have all that, and you can use it. And then, as I said at the very beginning, the trust issue is still there, and we do everything that nothing happens. Because the point is, if one thing happened, if your company, if somebody gets access to your company, to your data, and it's our fault, then the billions we spent into our cloud business, it's worthless, because we lost trust. So to get started, there's, first of all, under your seats, you see a brochure, Azure brochure, and also an Azure Pass. The Azure Pass gives you $100 for 90 days. You can use it or not. You can use it, for instance, for mining. But I will come to this point. It is not that lucrative. You can, of course, I will show you the sites afterwards. You can sign up. Just sign up on azure.com or portal.azure.com, and you get a $200 credit at the beginning, or you just have your account, and there are services for free and there are services that cost something. And then you give your credit card details, for instance, and then you pay for what you use. And if you use nothing, you pay nothing. Then there are, and that is probably very interesting for many people in this room, you have these MSDN dev subscriptions where you can sign up with your Live ID or your work account, and you, without anything, you get €25 per month. If you have a Visual Studio subscription from professional or enterprise, it goes up to $300 per month you get to test Azure. And as long as you have Visual Studio, the Visual Studio subscription. Yeah, and the last point, of course, is corporate. Corporate, as you get in contact with us, that has to be figured out separately. But it's also for corporations or enterprises, there's always the chance just to sign up and use it. So that's so far about Azure. And now we come to blockchain at Microsoft. As I said, it is really, one thing I just want to show you very quickly, the portal. When you get started with Azure and you sign up, you have a subscription you can use. The logic in Azure is that you have an account and you have a subscription in this account, and in this account you have different resource groups. So maybe first of all, there are two different portals. That is the old portal. Maybe someone of you knows that. It's the old portal, but it's not really used anymore. The features are moving more and more to the new portal, and almost all features are there. Maybe if you work with Active Directory, for instance, you will go to the classic portal. We call it classic portal from time to time, but the new portal is the way to go. So the idea is, or the logic behind the portal is, if you go to the portal and you sign in, you have the so-called resource groups. And within these resource groups, the idea behind the resource group is that you put everything together that has the same life cycle and the same context. For instance, if you develop an application, you have many different elements, like the app itself, maybe a storage, maybe a database. You have a virtual network and so on. It is all bundled into this resource group to make it easier to manage it. And for instance, you can then just delete everything with one click. So after some verifications. For instance, here we have this meetup demo resource group, and within that you have here different resources. I will go into detail what these mean, because I built a demo for this presentation, and the demo shall depict what this actually means. So you have these resources. But if you want to deploy a resource, you just go to plus, and you have here the marketplace. And in the marketplace is basically everything you have, or that is available on Azure. So, for instance, if you say you want to deploy Ubuntu machine, so you have here 7004 or 1604, and you can just click on it. I won't do that now, but you just enter some data in there, you click off create, and it takes some minutes, and then it's there. So for instance, maybe to show that, no, that's a bad idea. We have, like, what I will show you later is that I set up a miner. Much more, it is a virtual machine with a miner, so you can mine with it, and it's here. Oops. And then you can just connect with it via SSH, for instance, via PuTTY. That's one example. There are many different ways to do that. And you have your virtual machine then, and you can just use it. So much about Azure. But basically, we will deal with Azure now all the time. So blockchain at Microsoft. First I want to introduce how do we approach blockchain. And there are four key pillars for us that serve as orientation. So first of all, we have this aspect of openness. So for instance, if you take IBM, they focus on Hyperledger, on one single stack, blockchain stack. What we do, we say we don't build our own stack. We provide a platform where you can deploy many different, so of course you can always deploy your own virtual machine. That is always possible, and spin up or multiple machines, and you can spin up your own private network. But the idea is that we provide many different blockchain stacks in there. So we have like Ethereum, of course, we have Quorum, we have Quarter, we have Strato, we have Chain, and so on. You can just go there, and with some clicks, you deploy your own private network. If you ever did that by yourself and you tried that, it is a painful task, and it takes time and it takes a lot of knowledge. Of course, finally you need the knowledge to work with it afterwards, but this makes it really easy just to go there and to deploy it. The second point is integration, and that is where we are going to go. So at the moment, and I will show that on the next slide, what we are offering at the moment and what we are offering in the future. The idea is to have blockchain or the blockchain instances, or multiple blockchain instances, or even blockchain instances that are distributed over different clouds, for instance. There is a certain middle layer that enables the interoperability among all these different instances, and also the interaction with many different services. So in this context, Azure. So if you use, you have your blockchain like an Ethereum instance running, you can use Active Directory for authentication. You can use storage to store data. You can use databases, for instance, to store data in there. And it shall make this interaction, this connecting, and this, or even data analytics directly. To use it, it shall make it very easy. So we really want to come to a point where we have an integrated environment, and we have a fully managed blockchain layer. And it also should be possible then to exchange the instances that are running below this middle layer. The third point is cloud. The private instances are running in the cloud, in this case Azure. And I already explained the advantages, but this notion of to deploy it easily, to have it on demand, to have the scalability necessary. In this case, especially vertically, as it doesn't make sense to deploy more machines parallel. You have these advantages of the cloud already. And the last point, and it also goes hand in hand with the third point, cloud is of course security and compliance, what I elaborated already. So our offerings at the moment are, we have currently blockchain as a service. Blockchain as a service is, you go to Azure, and I will show it in a second, you go to Azure, you go to the marketplace, to the marketplace, select the category blockchain, select Ethereum, and then you just put in some data and it is deployed. So it goes very quickly, and then you can just, you can start working with this private instance. And it is not only that we provide different stacks so that you can create instances with it, we also provide dev tools like Truffle and TestRPC that are running in a virtual machine, so you can just spin up the machine and use it for development. And then, of course, you can connect the Truffle to the private network and deploy the smart contracts you create on Truffle directly to the private network. And what we are working on is blockchain fabric, Cryptlets, and the POC framework, where then Thomas will elaborate on. That is what we're working on at the moment. And as I said, this blockchain fabric is what I talked about, is this integrated environment we want to provide in the future. So when we go to customers, one question we usually get is, why should we use blockchain on Azure? And there are some reasons. It is what I talked about, it is the platform support, it is this aspect of openness, where you really have this multiple stacks available, where you have the tooling available and you can deploy it very easily. So we have a very easy to use deployment model, and it's not only that you can go to the portal and you have to go through the user interface, you can script it, of course, like with PowerShell, for instance. Or Azure command line interface, what you can also use on Linux machines. You have this aspect of compliance, what I already talked about. So we are the most compliant platform with over 30 standards we meet. So the idea behind this compliant aspect is if you as customer go to Azure, you should be sure that you can use the services that are provided there. That you don't have to think about, am I compliant if I put my data there? You should be it should be compliant by itself, and that is our target or our goal. And it is at the moment like that. Then we have the Azure marketplaces with all the offerings. We have the massive partner ecosystem. So if you say, well, I can't do it alone anymore, then we have a lot of partners ready to help you and to get started and to build your solution. We have this massive amount of Azure services, and what Thomas will go on, we have this innovation part that is going to come. And one thing I forgot, blockchain as a service offers also Hyperledger. So there's no reason to use IBM actually anymore. So the next point, so why then this can lead to a very ideological discussion. Why the hell should we use private chains? And it depends who uses the chain. Because when you talk with customers, if you take the context of enterprises, then they have certain requirements that public chains at the moment just don't meet. The first aspect is speed. We all probably know that there is the scalability problem. We're all trying to find a solution. Still, of course, also if you use private chains, you still have a distributed system, and it's also not like you can process like millions of transactions per second. But it is much faster as you can, and we come to the second point, also flexibility. You have a very high degree of customizability. You have the access to newest features. You can use different stacks. Think about what it means to have a change on a public chain. That's horrible. Think about if a company needs something very special and they use a public chain, that just doesn't work. So we need, in this case, we need a private chain. Then another point is ownership. So ownership. We have this managed versus public. If you, and it comes later, the legal part. As a company, or if you have a consortium, so you have many different organizations working together on one blockchain instance, you need to be in a legal context. You can't be, at the moment, if you go to public chains, it is somehow nebulous. It is, I'm still wondering that it is possible that I can put my money convert it to Bitcoin and transfer it somewhere. It is completely unregulated. It is, I don't know, and think about that. If you're a company and you go there and you do that, it just doesn't work. So they need this aspect of private and controlled. Of course, they have this more trust-bound relationship. So usually the participants in the network know each other. That's very different to the public network, where the assumption is you have a network of participants who don't know each other, and don't trust each other, and even with malicious players in there. So it is very different, and so it leads to different conditions. We have this legal aspect, as I already said. Then one aspect getting started is, so before this blockchain as a service, it was much more difficult to get started with private chains, as you had to set up yourself. But with blockchain as a service, this problem doesn't exist anymore, as you just go to Azure and you deploy it and it is there. Of course, in a public chain, it is also relatively easy if you have some experience with, for instance, command line and other stuff. So you can just spin up your node and you can connect and you can use it. That is also, of course, also easy. Maybe, and then the last point, and that is one of the most crucial points beside the speed aspect, is privacy. Think about, you have an insurance with a certain contract logic, and they put it on a public chain, and everybody can see it. Nobody wants that. They just don't want it. And so we need privacy. And of course, the public chains are also working on that to get some privacy, and there are some implementations already that maybe realized that, but so far, if you really want to have a private network, where you also have control over for instance, with Quorum, where you also have private transactions, you need to go with a private chain. So that are the reasons why private chains actually make sense, beside all this ideological stuff. So I want to go through one example where a private chain would make sense. So the context is you have a manufacturing company in Netherlands, and they want to import certain parts from a supplier in Singapore. So you have certain participants that take part in this process, and you have some authentication nodes. So that's different. So you don't have this proof of work. You have authentication nodes that do the verification. And yeah, so the process looks as follows. So the idea behind that is that you have a letter of credit. A letter of credit is if I, as importer, I buy something from an exporter, and he sends me the goods, then the exporter wants to be sure that he gets the money when I receive the goods. And that's what the process is about. So you have the importer and the exporter, and they agree. And so the smart contract is created with all the logic from the bank. You have the letter of credit is created by the bank. So this document is validated by all these authentication nodes. It is added to the blockchain, and now we can start a discussion now if it makes sense to store documents on the chain or not, or to store it off-chain, but let's assume that we just put it on the chain. So the advisor bank checks the letter of credit, notifies the exporter. So the exporter now starts to pack the goods to bring it to the shipping company. A bill of lading is created. Still, again, the authentication nodes check if this document is valid. So and verify the transaction, basically. So the goods are shipped to the port of Amsterdam. You have a custom certificate which verifies that everything is fine with the goods. The goods are transported to the importer. What is happening now? The importer says everything is fine, and then the money is transferred. It can happen automatically or not as soon as the importer triggers some function in the smart contract. And the payment is received. So when we look at this process and you think about how it would work at the moment, there are many different isolated systems, usually. And if you don't have this many isolated systems, you have some central system that is a central point of control. And the question then is, who has which control in this whole process? That's the first point. And the second point is all the paperwork related with it. Usually, when we talk with customers about such a process, they tell us not only that there are isolated systems, they tell us, well, there are now like 50 pages of paperwork, and we have to fax it somewhere, and then they check it and they fax it back, and or even it has to be real paper, it can't be faxed. And so, of course, we still have this legal issue because we don't know what the current state of smart contracts are. So the question is, if something goes on in a smart contract, what is the legal binding? But let's assume that we come to a point where we can be legally sure. Then you can put all this logic that is happening in all this paperwork, in all these isolated systems, you can put it on the chain in smart contracts. This overall, of course, automizes the process much more. You have less errors, you need less time, less cost. You make the overall process much more efficient and less costly. And finally, you have a logging layer that provides you with accountability, with auditability, and that very quickly. So there are many advantages why to use blockchain in such a scenario. Then there are, I went to a conference 2 weeks ago, and there was an interesting study from blockchainmonitor.com. They asked managers what they think are the most important use cases for blockchain. And they came up with this list. So that are the first 10, that's the ranking. And you see that this value transfer, this, especially in a financial sense, dominates this ranking. But what I think is really interesting is this know your customer and your identity stuff is at the very top. And I personally think, and that's my personal opinion, that that is one topic I talk with customers all the time, it is identity. And I personally think that identity will be one of the major use cases. And of course, we have all this cryptocurrency, and everybody talks about cryptocurrency, but cryptocurrency is just such a little use case of the overall potential blockchain actually has. So now, as I said, I wrote a demo. And what you see here is if you deploy an Ethereum network, you have two options. You have so I told you we have, when you sign up, you have the subscription. In the subscription, you have a resource group. So on the left, you have a single subscription private instance. What that means is that all nodes that are created and that are part of this network are within the same subscription. That is good for testing purposes, but usually you have multiple customers who have different subscriptions. So therefore, we created the second option. What you can do now is you spin up a private instance and you can connect from different subscriptions and so build your Ethereum network over different organizations and have a true consortium at the end. So then let's go to the demo. I just need 2 minutes. So maybe at the beginning I show you how we can deploy your own network. So you, as I said, you can go to the marketplace via the plus. We can go here and you see that you have your own category, and that's somehow an honor that that blockchain has an own category, and it shows which importance this technology actually plays for us. You go on blockchain, and you already see some suggestions. You go on see all. And what we have here are now different categories. Oops. Not so easy. So you see we have different categories here, like the single node ledgers and the multi-node ledgers. And what we are talking about now is really this aspect of the Ethereum networks. An Ethereum network or an Ethereum consortium in this case. And if you click on more here, you see all multi-node ledgers. In the case of multi-node, we have these available. So we have this, what I talked about, you have this single subscription. So it is easy to start with, just deploy it. The other one is also easy, but it takes a little bit more effort than to connect and so on. You click on that, click on create. And what you do then is you just fill out these fields. And the idea is also that we maybe at a later point provide a workshop where we can go through all the steps, maybe build an application together, that we really get the hands-on experience how we can use it. And what you have at the end is, if you created it, you have this Ethereum consortium available. And these are the resources that are necessary to spin this up and to use it. So the first thing I will do now, I want to show you, is how you can now connect to this network and that you see that there is actually a network running and you can use it. as I said, you can use PuTTY, for instance. So what you have these different nodes running there. And if you can define how many nodes you want to have, and the logic behind it is you have our transaction node that takes all the transactions, and you have mining nodes running in the background. So in this case, if you take the simplest case, you have 3 nodes running, 1 transaction node and 2 mining nodes. And it is a shielded network, so you really can't, you reach the transaction node or the network only via JSON RPC. The other ports are locked. You can't connect another node to it. What you can do, of course, is you can open the ports, you can do some port forwarding to get through all the firewall and so on, but then you create more or less a public chain, or at least a chain that is accessible for everyone. And that's not the idea behind that. So you get the information how to connect to. It is a little bit hidden, and if I find my mouse, yeah, it is hidden here. You click on that, and you get all the important information you need to connect to the network. So you can, first of all, you have an admin site. This is the admin site, and it helps you, for instance, if you need to send 1,000 Ether. So if you deploy such a network, the basic account that has been created is funded with, I think, 1 billion Ether or something like that. But a lot of Ether, so you can play around with. And you can, if you, for instance, take here MetaMask. So who of you knows MetaMask? Okay, good. So MetaMask is a really good tool to manage basically your keys. So you have your accounts there, and you can also connect to the public network, of course, and manage your Ether there. But this here is now connected to the private network. You can do this via. Okay, let's do it again. That looks good. Okay, theoretically there's a menu opening up, and when the menu opens up, there's an option where you can put in this address, and you see here the port there. It's for JSON RPC. So let's test it again. It is actually really important because I need it later. Whatsoever, we can't change it. No. Okay, theoretically, if you now copy this address here and put it in there, you will see that this account has 1,000 more Ether on it. And so you have more or less a proof that it is connected. And then that is MetaMask, and I will use it later also for, I wrote here a little demo, and if you send a transaction to the network, you have to authenticate somehow. So you can, of course, call an account on the node and say, and unlock the account, and then, but it is, in this case, it is easier. You don't want to connect to the node every time. So you have MetaMask running there, and if you send up a transaction, MetaMask will open up, will ask you, well, do you want to send this transaction? You say yes, and how much gas you want to use. And then it goes out and it uses the account, or in this case, it will use this account and will pay the transaction from this Ether available there. So now, if you want to connect to the network, as I said, we have here I have to copy it again. We have here this. So that's the username, and And what is important, usually you have port 22. If you go by SSH, in this case it is port 3000. And just click on open. You enter your password. So you're now on the transaction node, and if you look through the processes, there should be somewhere here. Here you see it is running in the background. So this is the transaction node, and you can now, and that is another important aspect, if you want to connect to a miner is not directly reachable from outside the network. So you have to go to the transaction node, and then from the transaction node to the mining node, if you want to go to the mining node. We can do that. No, it's not so. So you're connected with the network now. Before I go on with the demo, I want to show you how I got to the point that I have this demo running here. So there are many tools out there, of course, to code. So you have different things you have to think about. You need a certain tooling to develop the solution. That can be Visual Studio Code, what can be used on any platform like Linux, Mac, or Windows. There's also a Solidity extension. You can use Visual Studio, but you can also, of course, use Atom if you want to, like we did in our workshop. And for instance, you have now Visual Studio Code, and you have different elements now that make up this. Let's close this. Right. This make up the whole solution. And what we have is first of all, we have, of course, this Ethereum network running in Azure, as I just showed you. That is where the smart contract gets deployed to, and that's where the app is then connecting to or sending the transactions to. You have the application itself, or let's go on with the smart contracts. You have the smart contract, you have to create somehow the smart contract. What I did here is I wrote it here, and I wrote it and I used Truffle. And if you use Truffle, you can just, if you look at here, you can just, by taking this, you can connect directly to the Azure network. And if you run Truffle migrate, you can just migrate the smart contract you created to the Azure network and use it directly. Of course, you can also use test RPC and do it locally, but in this case, I wanted to deploy it to Azure, and there it goes. And it was this contract. This contract is not that complex. It has only, it has a certain, the idea is you have party R and party B, they create a contract, and there's a function, settle the contract, and it has a certain logging or auditing function, so you just, you can settle the contract. So you can get the state of the settlement, you can, and you can settle here. And at the end, and that is also important, is the ability to kill it. Usually you have some modifier in there like isCreator to avoid that everybody can kill the contract. But in this case I left it out, but I created it and you can just add it here and then it's fine. That's all I will show you. This is also, I created a repository where are many instructions where you can just get started, and where also this demo is, for instance, available. So we have the Ethereum network, we have the smart contract, but we also need the app. And the app usually has a front end and it has a back end. One thing I forgot is that this data here is not coming from the blockchain, it is stored in a database. So when I create a contract, the data that is related to the contract here is stored in a database. So what it does, we can go through it. So if I create a contract here now, so what I do, I showed you this contract here, and what it does if I click on submit is that it creates exactly this contract. So what you see now, or what you should see, okay. Well, we have the blockchain moment. Great. Where I reloaded. Let's try it again. Okay, I tell you what it does theoretically. We tested it. Is it coming? No, it's not coming. What should come now is, first, it should display you here the transaction hash. So there are two things that are happening in the background when you click on submit. The first thing is you go to the private network and you say create this contract. So you send a transaction, and I think I know what the problem is, because this is not opening up automatically. Yeah, here we go. That's the problem. So the problem why the transaction hash has never been created is that we never approved the transaction. We never signed it. So we do that now. And it will happen now. I will reject them all. Good. So what I will do now is I will just close my Chrome and will restart it. And it will take a minute, because that is really essential, because otherwise you just don't, it just makes no sense. Good. So let's try it again. We have this create contract. There's a new behavior. As soon as I move the Chrome over there, it just does not want to do it. So what I do now, so it works perfectly if I do it on my screen. It's a new behavior. We did it on purpose. So I submit this or no, the transaction. So what you see here now is that you have the transaction hash. It will now take a moment. What is happening now? The transaction is sent to the network. you have all this mining process, the block is created with the transaction, and when that is done and the contract has been deployed, you should see here, and it will take some time because this consortium is already running for some time, so that's a disadvantage of proof of work. The difficulty increases and increases even if I do nothing. So it is working now in the background, and as soon as the contract has been deployed, let's move on. I hope it will come. Perfect. So what you see here is now the contract address, and you also see that in the database I created in Azure, the row has been inserted. And if you go now over here, where is it? If you see here where's my mouse there? You see here the contract that has been created, and it's now actually on the chain. With this address, with Ralph and me, who have an unsettled contract. And what I do now is I will settle this contract. So as I showed you, there is a function, settle contract, in the smart contract, and if I click on settle, it will trigger this function and change our state variable in the contract to true. And also it will then change the data in the database to depict the new situation. So we click on here. Oh yeah, we have this again. Let's see. No. Okay, let's go back. So what it does now, of course I could have implemented an event, but I did it differently now. I have a function that, I query the transaction receipt. So I'm waiting for the transaction receipt to be available. And as soon as it is available, it will be shown here, and then it still, again, takes some time. Yeah. The great thing about working with blockchain is that you get a certain patience, because it all takes time. So that's the reason why to use under consensus mechanism. So what we see here now, there are twice, but you have here the transaction receipt, and you have here that the row has been updated. So it has a new status now. And if we reload this, I could have implemented it. You see here it is settled. And you see it is actually not difficult to spin up such a solution. And then you can go on. You can add more features. You can put an authentication layer on top of it with Active Directory, for instance. Or use other features, like I use the SQL database. And so you can really build powerful applications really easily and use blockchain as a one component of the overall solution. So the next step is now to give over to Thomas. The question is, do you want to take a short break because now it will be another hour, and it will be it has certain complexity in it. It has not so complex part, but it also has complex parts. So do you want a break? Yeah, do take a break.
So we're gonna take a 15 minutes break. We have drinks and sandwiches outside for you. The sandwiches and the soft drinks are free. I think the alcoholic beverages cost something, I'm not sure. But yeah, if you go right out the door, you will find them. And we'll be back in 15 minutes.
Okay, thank you.
Was ist eigentlich das Singen?
First, Johannes would like to show one thing at the beginning. I told her I was talking about the mining stuff.
Alright, so I should start letting people know that it'll be like 5 minutes or so.
Yeah.
Ja, das passt. Ich habe hier. Danke.
It's not just the connection has to work.
Ja, go ahead.
So one last thing before my colleague Thomas will go on. I was talking about this mining aspect, and I just want to show you how well mining works on Azure. So if you go to Azure, let's do it differently. So that's easier. So a colleague of mine, Vincent van Wingergen, wrote a very nice blog post about Ethereum mining in Azure, and he looked how performant it is. And if you want to mine on Azure, you have basically two options, or two serious types of VMs you can use. There are the NV and the NC machines who have really powerful GPUs in there, so they use, for instance, NVIDIA Tesla M60. So there are multiple of them. So, and you see like 112 gigabyte of memory, so that are really powerful machines, and you could, maybe you already know why it's not worth it, because they're really expensive. But if you nonetheless want to do it, you can of course deploy the machine and install the software like ETH Miner, and you can let it run then. And if you look at the hash rate, and you don't see it here, but it's around 30 mega hashes. And if you know how much 30 mega hashes, how much ether that brings, it is not much, considering the costs of the machine. So it brings you like $3 per day, and you pay more per day for the VM. So it is great for testing. It's great for playing around. It's great if you have a dev subscription, but nonetheless you make no money. It's not worth it. It's just a waste of resources, a complete waste. But it's nice to play around with it. And if you go to this blog post here, or to this repository, you will have, so here you have your tutorial how you can do that. So it's just GitHub blockchain repos. And what he really did, and that's really great, he looked at it and he evaluated the different machine sizes and if they're worth it. So, and you see it is just not VM price covered, you see it, how much of the VM price is covered. So, should try it, it's fun. It's nice to see the mining just to test it, but yeah, that's it. So I just wanted to show you that. Thank you.
You can try with the free.
Oh yeah, like $100. You make like 10 cents, I don't know, maybe €1. Okay.
Yeah. Maybe if you use many Azure passes and you can print some money. I'm not sure. Okay, thank you, Johannes. Okay. Hello, everyone. Oh, bad start. Better. Okay. So, yeah, thank you, Johannes. Fantastic demo, and it even worked in the end. So I just want to go a bit further in what we're doing with blockchain at Microsoft. So maybe more kind of a roadmap kind of thing. So the project we're working on right now. So I've been doing blockchain at Microsoft for a little while now, and I've been involved in kind of customer prototyping and also some of the projects we are doing internally. so in order to just position this stuff and what we are doing it, I just want to give you an example of a customer engagement we did on blockchain, and then how it, how it kind of inspires what we have to do on blockchain to help those customers. So of course, there's lots of customer experimentation on blockchain and Ethereum. A lot of them are confidential, in the financial sector or industry and stuff like that. We are lucky to have one partner who was eager to share the experience and the information. So this is a company called Utilidex in the UK, and they do energy trading, so more like B2B energy trading. So you know that energy is kind of one of the big use cases outside of digital currencies, but one of the big use cases for blockchain. There were some quite infamous companies who worked on that, and it's very, there's a lot of interest from energy companies in all countries. So Utilidex, so basically they looked at the blockchain, and like many customers, they were really excited. And so they asked us, can you help us look at this? And we basically went through this blockchain as a service stuff, getting started, truffle, smart contract programming, and this is not so complicated actually, and putting a simple trading contract using Solidity and this stuff is not it's not super complicated, right? It's doable. So after a while they saw, hey, looks like this is working, this blockchain thing. So, but do you think we could really use that in production? I mean, how can we deploy this effectively if we wanted to use it for real, with real customers? So that was kind of a, good question, I don't know. So that's where we kind of dug a little bit deeper into beyond doing the simple smart contract. What do you need to actually deploy a blockchain app, potentially? They didn't do that yet, but they are closer now, hopefully, than they were. And so the thing that we saw, and this is probably very hard to read, but the idea is that the blockchain is just a piece, right, of a platform, right? So you have to put the blockchain, whatever ledger technology you use, but let's say Ethereum, you have to put it in some kind of context. You need to authenticate your users. You need to figure out who they are. You need logins and passwords. You need to manage their private keys. Because MetaMask is cool, but if you are looking at business-to-business applications, you have many users, many different companies. You need to authenticate them. You cannot probably trust them to manage their private keys properly. Well, you're not sure. So you need some form of authentication stuff going on. Probably you need a couple off-chain, off-chain things, right? You need a database, a regular database. You need some storage. You need a bunch of stuff. And then you need to secure all that stuff reasonably, so you have a bunch of different partners. They are located in different places in the world. You need to figure out a way to tie all these things together. Again, we are on the context is private blockchain, right? Private blockchain means that probably they have a VPN running between the different members or something like that, or a private network. So we went through all this stuff with them, and we got it to work, which is the good news. But definitely the conclusion is that the core blockchain technology, like the Ethereum, let's say, platform, is key. Of course, it's the new building block. But you always need around all the usual, I would say, architectural and technical blocks to make it work, to make it accessible, to secure it, and stuff like that. So, it's the kind of experience we've seen again and again with customers, is that getting the first smart contract written is not so complicated, but setting up all this stuff, and standing up the blockchain, as we've seen, a private Ethereum blockchain is really, really easy, because we have those pre-ready templates. But all the stuff around, that's a lot of work. Okay, and it's just traditional, infrastructure, I would say. There's nothing especially new. Maybe some specific things related to blockchain, But basically, that's what we saw time and time again. And so that's typically this UtilityX, I would say, context or problem is what we're trying to work on at Microsoft, is enabling this blockchain technology for traditional enterprises, traditional customers who have some IT and some constraints, and how can we help them adopt the technology, typically blockchain, typically Ethereum. Because there's a bunch of things we see also fairly quickly when we try these things. The consensus algorithm, as you saw, we have to wait an indeterminate amount of seconds to get our blocks mined, just because there's this proof of work going on, which is not completely useful in the private context. So that would be one thing. Some customers are also worried about this whole transactions being broadcast in the clear to everybody, so everybody seeing all transactions. That's really cool in the public blockchain space. In the private blockchain space, it might be different. So there's a bunch of questions like that, and that's the type of things we are trying to work on. So in a couple different ways. I'm going to talk about our work in the Enterprise Ethereum Alliance, and then our work on something we call the fabric, the Cryptlet fabric. So the idea is to give some context around the blockchain technology so that it's actually usable, right, by enterprise customers. So if you are interested in UtilityX, maybe we'll circulate the deck later, I'm not sure, but if you look for UtilityX, blockchain, Microsoft, you'll find a bunch of things. We wrote a technical white paper, we got some source code if you want to look at that, so there's some smart contracts in there and a whole lot of other things, authentication, key management, I'll talk a bit more about that. So we're definitely working on that aspect, is make it simpler to not only start a blockchain, but the whole platform, right? The blockchain, authentication, the key management, the off-chain storage, stuff like that. So kind of a framework that helps setting up the whole platform. But in the meantime, one thing we found really interesting to invest in is the Enterprise Ethereum Alliance. So I think that's of good interest for the Ethereum community. So you've probably heard of it. There's a bunch of founding members, lots of financial institutions, of course, as usual. And a bunch of, I would say, technology vendors like ourselves, and Intel, and among others. So the idea is that, so you've seen that there's quite a few consortiums like this. R3 is another consortium of banks mostly. So the idea is that these guys, they're basically trying to figure out a way to work together, right, through blockchain. And because blockchain is not so fun when you are alone in your corner. So all these guys, they want to build the technology and also build the infrastructure, the shared infrastructure, so that they can do business together on the blockchain. So that's pretty cool. And so I just wanted to say a few words about the Enterprise Ethereum Alliance, aka EEA. So basically, they Ethereum. Why Ethereum? So basically, I'm sure if you are here that you would agree this is the most popular and most attractive blockchain for developers. Certainly the one that has customers the most excited. Mostly because of the smart contract concept. So maybe the name got them a bit confused, but they see the potential in having agreed code that runs on the blockchain, where automated actions can take place. So it's definitely very popular. And what we've seen is that enterprises have been doing what I described, right? They take Ethereum and they kind of try and tweak it to use it in a private setting. Private setting meaning that you have a small number of members. You don't have thousands and thousands like the public blockchain. You have a few, maybe 10, 30, definitely less than 100 probably members. So they kind of tweak it for that, and we've seen a few examples. BHP, Billiton, the oil company we worked with, and most. I will talk again about JP Morgan Chase, who worked a lot on Ethereum for that. So, people were definitely using Ethereum in the enterprise context, but they were finding some limitations, as we discussed. So, basically, why go for Ethereum and not Hyperledger or Corda? Well, there's a bunch of interesting things. They are all open source. Ethereum has much more literature, and you have lots of tutorials, getting started, documentation. If you look for the same, for Corda, for example, there's much less information and much less examples. So, Ethereum is really easier to get started with. There's a big ecosystem of startups and that are building on top of Ethereum. There's a bunch of them in Brooklyn around the Consensus. Consensus is this commercial entity that backs or works on Ethereum. So there's a bunch of startups doing development tools and alternate implementations. That's really cool. One of the things we find the most interesting is that because it's running a public blockchain, it means that it gets the attacks and basically the security level you need to run a public blockchain, which is really powerful because, I think Ethereum is probably attacked probably as much as Bitcoin now. So after a while, and hopefully not too many forks, they'll get it right. I mean, it will work. So that's really powerful, again, compared to some private blockchain implementations that are just private. If you take the two others that I cited, they are only private, so they have less security, I would say, proof going on. So that's, really useful. And, and it's been proven already. Well, there's lots of ICOs going on and stuff like that. So this thing works, basically. So that's cool. So the idea of the EEA is to take, I would say, the public Ethereum, right, standard or existing technology, and adapt it, right, to the enterprise by solving a few immediate problems that I will discuss, but keeping it compatible with public Ethereum. So typically, for anyone, for a customer, the idea would be I'm going to write a bunch of smart contracts and I'm going to learn how that works, because there's some, you need to be a bit careful. Use smart contracts, I'm going to learn about that. I'm going to deploy them in private blockchains to see how it all works. I'm going to work with a few of my partners. And then maybe at some point, I will open up this whole thing to the public blockchain, right? So that would be the ideal. So they wouldn't have to change anything to change the smart contracts, just take the smart contracts and publish them to the public blockchain. So it will remain fully compatible. That's the goal. How are they going to do that? There's big users of Ethereum in the alliance, so I'm going to mention JP Morgan again, and a bunch of startups, especially consensus startups like Block Apps. These guys have already worked on special implementations of Ethereum, so they know the protocol very well. And there's also other companies that have built on top of Ethereum, like Monax, real deep technical companies that really have the expertise to find the right solution. So that's cool. So I'll give you some links if you're interested in looking at the details. What I have is some really high level here goals that they have for Ethereum, this enterprise Ethereum implementation. But there's a lot of details, of course, and lots of deep technical conversations going on. And interesting conversations. So basically, the first thing that pretty much everybody asks for is a specific consensus algorithm for private blockchains. So the first thing the UtilityDex IT guys said is that we're not going to have 100 machines cranking up the CPU all the time, mining proof of work. That doesn't make any sense. So you can discuss that, but you can understand that in a private setting with maybe 10 members, it doesn't make much sense. Especially if you go for pure proof of work. if you have 10 members and one of the members decides to start 100 machines, then they basically own the chain. So yeah, what's the point? So a different consensus algorithm seems kind of mandatory for. So we have prototypes and pilots even using the normal public Ethereum nodes and consensus. It works, it's fine. You get into some little vexing problems, like the difficulty goes up and then it takes a few seconds or minutes to mine your transactions. It's a bit, but it's okay, it works. But, so for example, the guys at Parity, it's another client, Ethereum client, they have a very fast consensus algorithm, which is not really a consensus algorithm, called proof of authority. So basically, you can hard code the addresses of the nodes that have the right to mine the transactions, and that's it. There's no more consensus, so it's very fast. And we've been using that in some POCs, but it's not really a consensus algorithm. But for development, for example, or testing, it goes very fast. But what we need is a proper, algorithm, but that works in a private setting. That's fast enough. The other thing that's been asked for many times is this. Data privacy, permissioning, something that makes it possible for two members of the consortium to exchange a transaction without the other members seeing the contents of the transaction. So basically private transactions somehow. So usually the idea is that, for example, UtilityX, they have many companies trading energy and they are competitors. Right? They are competitors with each other, most of them. So they are doing offers and bids on blocks of energy. They don't want the other guys to see how much they are bidding, obviously. So they're okay that everybody is mining, everybody has the ledger, that's cool, but they want the content to be private. So there's a bunch of stuff that has been done. You can encrypt data, you can store stuff off-chain, etc. But basically, we would like the proper way to do it, implemented, and we just have to use it and not reinvent this stuff because we've spent days and days reinventing this again and again. So it would be good if there's a definitive solution. So that's kind of the things that the Alliance is working on. So they have a website, that's cool. And from the website, or otherwise they have a wiki somewhere where you can, and they have some Google groups, mailing lists, where you can track what's going on and the discussions and stuff like that, and they do. There's some community, you can get involved as well. They're definitely looking for input from customers, in different industries like banking, insurance, etc. And I'm sure they would love technical help as well. And so the first thing, I mentioned JP Morgan a couple of times. So JP Morgan, what they donated to the Alliance, I'm not sure they officially donated it or if the Alliance is just going to use that as a starting point. It's called Quorum. So Quorum is a fork of Geth, so the Go Ethereum client that JP Morgan built, They've been using it for a little while. And they've open sourced it, and the EEA is using that as a starting point, okay? So it doesn't mean that Quorum is going to be the official EEA implementation. Maybe it will be, maybe it won't. But they're starting from there, and they are, exploring, because ideally they would like to have a way to have a pluggable consensus algorithm so you can choose which one you want, right? And Quorum doesn't have that. It has an alternate algorithm. So basically, Quorum does quite a few of the things that that we want. So within the single blockchain, normal Ethereum blockchain, they can support public and private transactions. Okay, through a fairly complicated architecture, I would say, but called Constellation. So Constellation is the implementation of that part. So it kind of complicates the design, but it works, and it's a working implementation. So Constellation, basically, what they do is that they have implemented this idea of encrypting the contents of the private transactions. So when you have a private transaction, the transaction only has a hash, and then you have to go to this transaction manager guy to get the actual data, right? And then the transaction manager can check the identity of the node to make sure the node is allowed to get this data. So the blockchain is perfectly normal. That's a nice design. It's the normal Ethereum blockchain with an addition on the side, for managing this encrypted payload. So that's nice, and they have a crypto enclave or whatever, crypto component that does the cryptographic stuff. So that's pretty cool. And they have an alternate consensus algorithm. So there are quite a few floating around. You may have heard of Tendermint is one that's mentioned fairly often. They've built something. They call it Quorum chain, right? And I guess, as the name implies, it's vote-based. So basically, they actually use a smart contract to count the votes for blocks. So some of the nodes create blocks, and so these are block makers. And then the voters have to approve the blocks, and they have to vote. And if a block gets a majority of votes, then it's appended to the blockchain. So it's a vote-based algorithm with some subtleties because you can have several makers. Well, but it's fairly sophisticated and practical, right? So it means that it's much faster than the normal Ethereum implementation in a private setting because you don't have the proof of work going on. So your CPU is not pegged at 100% all the time, and it's able to process many transactions per second. Hundreds might be a bit of an overstatement, I'm not sure, but definitely faster than normal Ethereum. So if you want to, I would encourage you to have a look at Quorum if you're interested in the private blockchain kind of stuff. We have in the Azure marketplace, we have those Quorum templates that you can use. So we have a single member that will deploy many nodes. So you have the one node version and you have the many nodes version. So both are good, I guess. So if you go to the portal, so basically the way it works is that you go to the portal and you search for Quorum. So the way to create something in Azure is to go up there, and I think my screen resolution is probably a bit too high. You type Quorum, and you get two of those. Right. Quorum demo is a single node version, and single member blockchain network is the name is not super clear, but it's the actual network. So it will create a bunch of different nodes, like block makers, etc. So you can try both. The single node version is easier to get started because it's just one virtual machine. Okay, and just if you have to real quick idea of how it works. So when you install it, they have a simple demo called the 7 nodes demo. So the idea is that you have this very simple smart contract that is installed automatically when you start the demo, okay? So it's a simple storage contract, okay? So this is a constructor, you have an initial value, and then you can set and get, okay? Cannot be simpler than that. So the subtlety is that when the script installs this smart contract, so this is the source code of the installation procedure. So as you might know or not, but deploying a smart contract on the blockchain it's a simple transaction. It's a normal transaction, I would say. You send the code, the bytecode to the blockchain. So this is the code that you would use to create a new smart contract. They've extended. What they've done is they extended the API with this private for parameter that is not there in the normal Ethereum. And this one means the smart contract, is private for the node which is creating it. I'm creating it from node 1, for example, and this other guy. So this is a public key associated to the node, one of the nodes in the network. So all the nodes have a key pair, public-private key pair to identify them. And so basically here it's saying this contract is private between node 1 and node, just happens, I know it's node 7, that has this public key. So when you create the contract, you can say, who are the parties who will see the transactions. And then on the per transaction basis, you can also send transaction privately. And so it's not, very, very hard to do that stuff. If we looked at connection right by peer, it's not particularly good news, this. Okay. Okay. So just to give you an idea, yeah. So this is node 1. That should be node 1. So let's say I do a private get here. I have a value of 42, so I'm on node 1 here, okay? And if I do a get here, I get 0, and if I do a get here, I get 42. So, I have node 1, 2, and 7. So if from node 1, I do again a set, so on node 1, I'm calling the smart contract, the set function. That's the way I would do it. I'm setting it to 99. But I'm saying this is a private transaction for, again, the public key of the node, the destination node, if you want. So I get the transaction here. And if I know to node 7, I have 99. So you saw that the transaction was mined really fast. There's no proof of work going on. And on node 2, I still have 0. So node 2 doesn't see the value that's passed as a smart contract. So the transaction is private between those two nodes. And it's, it's easy to, well, there's nothing to do, right? There's this new API you need to use, and that's it. So it's pretty cool. And I can tell you that with the real customer scenarios, it's very, very useful, because that's what a lot of customers want to do. So you can try Quorum. If you want, if you're interested in private blockchain, it's definitely, pretty promising, platform. And in closing, I would like to close with this notion of Cryptlets that Johannes mentioned. So Cryptlets is something that we've been working on for a little while now. So if you want to read more about it, if you look for Cryptlets, you should land on this page. Project Bletchley, the Cryptlet fabric, where we have a long white paper. In blockchain space, you always have to have your white paper. So we have our white paper. So you can look at the details, and the idea is to give you a kind of an overview. So we're still in the same idea of the blockchain works. In the private space, we're working on it. It's getting there. But we still have this, I would say, issue of, this is probably way too small to read, but this issue that a blockchain app is not alone. I mean, you need the blockchain engine, if you want, platform, but you need a bunch of other stuff, right? You need identity, you need off-chain storage, you need maybe analytics, security, you need a bunch of things, right? So the Cryptlet fabric is this goal that we have of building a platform that will be integrated with major blockchain platforms, infrastructure, and basically we'll be able to connect your smart contracts in a secure fashion to a number of services. And we are mainly thinking about identity, key management, off-chain storage, okay, in a standard way. So that if you need off-chain storage from your smart contract in Ethereum, Enterprise, or Corda, you'll be able to just use this fabric, this Cryptlet fabric, to get to this functionality. Right now, today, all this stuff you have to build yourself. There's no real, well, there's a couple, not really frameworks, there's a couple startups, there's a couple products out there. There's some hints of what you should do, but you have to build most of it yourself, right? Using techniques that are kind of as secure as you can make them, right? Because there's a lot of complexity in attestation, signing, cryptography, and all that stuff. So our idea is to build a platform like this that's ready to use. So in a little bit more detail, the first thing we have is Azure, we mentioned. So we can basically run code in the cloud, right? That's kind of obvious. The thing that's maybe less obvious is that when you are using enterprise Ethereum or any blockchain and smart contracts, the smart contract code is executed by all the nodes in the network, right? So you have a network of nodes. You call a function on the smart contract, that's part of a transaction. The code is executed by every single node in the network, right? It has to be, because all the nodes will check that the inputs and outputs match, right? Our idea is that, this kind of limits blockchain scalability, and maybe we could help with by executing some of this code outside of the blockchain and inside the secure cloud environment. The other thing that we have is in Azure is something called Key Vault. So key management is kind of one of the pains, again, talking to customers. We show them how this works, we show them MetaMask, and they say, where's the key? It's stored on the user's PC, that's not going to work. So you need some form of key management, right? It just happens that we have something called Key Vault. It's a module called HSM, a hardware secure module. So it's basically a vault that can store secrets, like keys, okay? So typically you can put your private key inside that vault. But the next good thing it can do is that once you put the private key inside, you never have to take it out, because the vault can do signing and encryption for you. So when you need to sign a piece of data, you send the data to the vault signs it using your private key, and then sends you the signature. So you never have to take the private key out of the vault, okay? So it's protected, it's not lost, it's managed, you can secure its access, you can revoke the key when the employee leaves the company, etc., etc. That's really very useful for blockchain scenarios in the enterprise. We have something called Azure Active Directory, which allows authentication. So, how do you figure out whose key is which? Well, you authenticate the user, and you say, hey, Thomas' key is this one, okay? So you need a way to authenticate the users, and we have that, that's cool. And the last piece is that we need a way to execute the code in a manner that you can trust, right? So recently there's been talks of enclaves for a little while, but recently Intel, I say recently, it's a couple years really, but these things are fairly complicated. Intel released an architecture called SGX, which is basically in the latest, I think it's Skylake architecture of Intel. You can create these enclaves, and the enclave is a piece of memory, inside the chip, inside the computer, but that the CPU isolates from the rest, okay? So that no process, not even the OS, nothing can modify the inside of that enclave, so that the code that is stored inside the enclave and run in the enclave is secure and cannot be modified, right? And it also gives you attested proofs, so you can have basically kind of a hash or a signature of the code, so that you can check that the code hasn't been modified. So when you can basically call, let's say, a service, and the service will return a result and a signature, and you can check, hey, okay, this is the actual original code that was uploaded by the developer in the enclave, or whatever, the maintainer in the enclave. So the idea of this stuff is to, because one of the, I would say, the worries of enterprise customers when they run code in the cloud is, what if my cloud provider is going to modify my code inside the machine? After all, you are admin on the machines, you could go and change something. With that, we can't, because if we do, but first we can't, but even if we manage to, the proof changes and you can see that the code has been modified. So that's a bunch of stuff that allows us, so, lots of resources in our data centers. We can create keys on the fly, manage them for you. You can authenticate the users. We can use this HSM thing to do signatures. So all in all, we have this nice end-to-end kind of, I would say, environment, which is really nice for a blockchain application where we can authenticate, manage keys, do signatures and stuff like that. So these are the building blocks, I would say. And what are we trying to build with that? Something called Cryptlets. So a couple ways, so Cryptlets are basically secure code execution in the cloud, right, from your blockchain environment. So from your smart contract, in some way, you want to execute code that is outside the smart contract virtual machine. Because you know that the EVM, the Ethereum virtual machine, is closed, right? So from the smart contract, you cannot call a web service, you cannot access the disk, you cannot do anything, right? Yeah, for a number of reasons, but for repeatability of the code. So the idea here is to be able to extend the smart contract code and call out to some other systems through Cryptlets. Why would you want to do that? You want to get the price of the dollar from your smart contract. You cannot do that today. There's no way, right? You have to cheat, okay? So for a smart contract, as long as you are dealing with, pure blockchains, you are okay. But if you do a smart contract that you want the smart contract to automatically, for example, do something when the dollar reaches that value, how do you tell the value of the dollar to the smart contract? That's the problem. So people have been using something called oracles. So oracles, it's kind of not a product or whatever. It's the idea that you can have processes running somewhere, and basically they call the smart contract from time to time, and they tell the smart contract, here's the price of the dollar. Here's the euro-dollar rate or whatever. Here's the euro-dollar rate. Every minute gives the euro-dollar rate to the smart contract. Not super efficient, but that's what people have to do right now. So the idea is to replace this oracle with Cryptlets. That's something that's a bit more solid in order for you to be able to get information from the outside. And that's the simple case. Basically, my smart contract wants to retrieve some information from the outside. The slightly more complex case, and that's where enclaves and secure execution become more important, is that I basically have part of my smart contract code running outside of the blockchain. It's running somewhere else, right? It's doing something. So the basic idea of that is, you have a smart contract that needs to call into a legacy system, an existing system. Finance and banks are full of those. A CRM system, anything. It needs to execute some code, right, that is going to touch an external system, but you still want the guarantee that the code is not, you want to be able to trust the code, although it's not running inside the blockchain. So here the idea is more like your smart contract is cut in two. There's a part that runs in the blockchain, and there's a part that runs outside in a contract Cryptlet. And that also gives you a couple interesting benefits. You can encrypt communication. You can do secure computation. So you can use algorithms that people cannot see in the blockchain. You can scale, right? You can scale. If you have some complex computations to do, you can do them on a, in a real full, I would say, execution environment instead of trying to do everything in a smart contract. Yeah, it gives you a few nice benefits. So just to get a bit more details on that. So what we call the utility contract is the simple case of like Oracle-like functionality. So it's actually pretty simple. So you have a smart contract. So the formula there is not very simple. I've been told it's a swap pricing formula, but I wouldn't know. But the idea is that the smart contract has some business logic, it's calculating something, it's figuring out, you know, an interest rate, it's figuring out how much to pay someone, whatever. It has some logic. It needs an external piece of data, right? It's going to use a Cryptlet to get this information. So for example, the Cryptlet every day at 4 p.m., you know, finds a couple values on the market and sends them securely to the smart contract, okay? So that's exactly what an Oracle does. What the Cryptlet gives you is the framework to deploy your code securely in Azure. Is giving you the proofs, okay? So is the host the right one? I want to check the certificate over the communication to make sure, you know, it's the right host. I want to check maybe the code attestation to make sure the code hasn't been modified. So you get a signed, you know, nice piece of data that you can use in the smart contract. And so basically the way, you know, it would work is that there would be a kind of binding between the contract and the Cryptlet. So some shared secrets that would allow the contract to make sure that it's talking to the right Cryptlet. And basically we would give you the framework to do that. And the contract Cryptlet, as I mentioned, is a kind of a different, so that's really where, you know, we're looking at really changing the model in a way. So that's a bit more, I would say, forward thinking, because we are kind of getting out of the model of smart contracts being executed on the blockchain. And we are saying, okay, the smart contract is basically used to keep track of invocation results or transaction results. So it's really used as a kind of simple ledger. It can do more, of course, but, you know, for example, we would just have the minimum amount of code in the smart contract, and it will you know, surrogate, so delegate the execution of the code to a Cryptlet running in the cloud. So again, we see our complex formula there. So the computation is not done in the smart contract anymore. It's done, you know, in the cloud. So the smart contract can still keep track of who did what, of, you know, consensus and stuff like that. But the complex calculation is entirely done in the cloud. So the algorithm can be secret. Nobody will be able to look at it. And it can scale, can be a complex calculation running on a fast host. So yeah, you get a bunch of benefits like this. So again, same here. You know, the framework would give you the necessary, I would say, you know, shared secrets and infrastructure to make sure that I'm calling to the right Cryptlet, you know, enclave, that nobody touched the code, that it's the right host. So you get a bunch of signatures around your data to, well, the data and the transmission to make sure that it's not been modified. So yeah, that's kind of Cryptlets in a, I would say, in a nutshell. So, you know, I think we conclude with this big, you know, wow, eye-popping schema. So the goal of all this stuff, right, is to build something that works on all blockchains, that communicates securely to a bunch of services. So you will be able to write your own services, of course, you know, Cryptlets. You will have a framework and everything. But the vision is that we would give you ready-to-use services as well. So identity, authentication, cryptography would be really ready to use. So you would just have to, you know, include the right library and make the right calls, and we would do this, all this stuff for you dynamically. And we can think, of course, of exposing a lot of Azure services in that way. So there's, you know, lots of potential, but we are still, you know, still working on the basic. Well, the platform, we have some internal releases right now, some private previews. So we are building the thing from the bottom up, and the first thing to get right is the fabric infrastructure and the frameworks. So if you are interested in all that stuff, really, Cryptlets, of course, but yeah, if you are interested by any blockchain thing and you would like, you know, to keep track of what we are doing, we have a bunch of links, and certainly, you know, the AKMS blockchain preview, if you are interested in seeing some of the code and using it, if you have a use case, very happy to, you know, work with you. And we have a bunch of technical communities for blockchain around, you know, if you want to join that as well. And I think that's what I had. Shall we do some questions, maybe? You want to pass that around, or people will shout?
Yeah, do you have questions probably? So yeah, they have questions. So.
They have questions. Yeah.
They have questions, so yeah, we should. Okay, yeah, let's start there.
For the Cryptlets, is that something then that becomes part of, is it open sourced and becomes part of the whole ecosystem, or is it something that's going to be stay within Azure only?
Yeah, sorry, no, the goal is to have all open source. So fantastic. So the goal is to have, it's all open source. So we are building it right now, privately with a few customers, but the goal is to release the source code so that it's usable by anyone. Actually, the goal is not for us to implement all that stuff. We would be very happy if the community who did some of the work. So the idea is to build a framework and then have as many hands as possible working on the thing.
I have 2 questions towards Quorum.
Okay.
So you talked about private transactions which are encrypted, and this is sort of in competition with double spend detection, because if I don't know what the semantic contents of a transaction is, I don't know if it has been double spent or not. So what's the story here? So let's say we have a private communication channel, and then we exchange value, and then you decide to send it further. How does this work with private and double spend detection?
So from the network perspective, it's a normal transaction, right? It's mined by everybody. Just the content is opaque, and the content is encrypted somewhere. And so the content is just a bunch of JSON properties. And so both parties have to understand the schema and what they are trying to do, for sure. Kind of like the ABI for contract.
So this means that somebody, if we have a confidential transaction with each other, the miner or the block validator and the voters have no idea if that is semantically correct or not.
No, what with the call you made, I mean, well, it is because what the miners see is just an opaque value, right? Yeah. So what do they need to do? They need to execute the code, right? And so the private nodes have executed the code. They have validated that it's correct. Only they stored the result in an encrypted place.
Okay. I can imagine that works.
So it's kind of, you have 2 states. You have a public state and a private state, and they're different, and they manage both.
Okay, I think this is a difficult question probably to talk about fully in the end. So let's maybe talk about that.
We can look it up. Yeah.
Okay.
My question actually connects to Andreas' question. So, do you plan to integrate TrueBit-like full hash qualification of transaction stages? And do you plan to support a mechanism where there is a proof of correctness for the transaction system which can be decoupled from the actual semantics of the processing which is necessary to find the proper transaction values? So in principle you could split the two and provide an interface where we are basically implementing a transaction-based level for the usual account transformations. So the key of the question is, do you plan to support like TrueBit complete auditing of those parts of the transactions which could be in principle proven to be correct as being no double spending?
Okay, so I don't have that deep vision on the implementation details, I would say. For Quorum, Quorum is JP Morgan's fork, so that's one thing. And Cryptlets is kind of another different thing that we are working on. And they might be a little bit competitive, I would say. But so for our part, we are mostly residing on top of the enclaves and HGX stuff to prove or attest that the code was the original one. and we are not going to try and validate more than that, I guess. So what we get is that we send a transaction to a node, we verify the host identity, we get a result, we verify the code was not tampered with, that the host that replies, is the original one, I mean, the certificates and everything. And from that perspective, I don't think that we are going to validate that, more than that. Also because it's centralized execution, right? It's centralized, it's not distributed, it's centralized execution. For Cryptlets. And for Quorum, I will have to look it up because it might be different in case.
But in principle, you could provide the support for hashing of transaction stages and then provide a root hash which qualifies that the different stages of the transaction have been registered properly. And the question would just be if you provide encapsulation or insulation between the transaction level of the system, which has to be covered in order to avoid double spending, and the computation level, which you're trying to abstract. And so one point also to question is if there would be an ability to enable redundancy, like having the contract computed not only within one execution environment, maybe doing one there and one there and qualifying if they do result in the same output.
So a couple things there. So definitely we're looking at more like centralized execution. We are not changing nobody is changing the way the Ethereum blockchain works, right? Nobody's changing the way the transactions are mined and processes. We are trying to add, because that's really core to the protocol, and we certainly don't want to mess with that. So the idea is to find the right entry points to, without touching the normal operation of the blockchain, being able to add some value in there. Mostly Oracle-based, external execution, but not necessarily changing the way. So, maybe in the EA they will look at some deeper protocol changes, but honestly, I know where the discussions are for that.
Okay. Okay. Is there another question? Sorry. Yeah.
Yes.
Two questions actually, but first maybe something for Andreas. So I don't really have looked at Quorum in that much detail, but I've listened to all the Enterprise Alliance announcements. So as far as I understand this, in the private transactions, basically you're only ever committing a hash of a state onto the chain. So it's basically like a state channel on a public chain. It's a similar idea, but of course those different state channels cannot communicate with each other. And so now they have partnered up with the Zcash team to introduce Zcash NUGs to enable this communication between those different channels on the Quorum chain. But I don't know the details. My questions. First, regarding the Cryptlets, the example where you have a Cryptlet essentially fetches data from another source. Am I right to assume that basically you would fetch this data from a source that would sign it, and then you would verify the signature inside the secure enclave, because I guess you cannot have I/O inside the secure enclave itself, right?
Yeah. So there's a kind of circles of verification. So obviously, if the original source of the data has to somehow attest that he's the original source, and then we get that, we put it in a packet, then we add our own attestation around it, and we pass the whole thing. So you get this onion rings of signatures around the data.
Okay. My second question is regarding the enterprise Ethereum stuff in general. Ethereum is a very immature ecosystem. There are a lot of issues that I encounter. For example, if you run a GEF or something, syncing of the blockchain might just stall for a minute or even longer, or you might have to restart the client sometimes. And as an end user, okay, you can deal with this, especially if you're a blockchain enthusiast. But I think in the enterprise environment, you need reliable systems, and Ethereum is still very immature in that regard. And so I guess it's okay for the proof of concept stage right now, but eventually this proof of concept should move into production. And how do you see this evolving? I mean, there this is probably still going to take years until it's going to be production ready or something.
Yeah, probably take. So when you mean in production, you mean on the public blockchain or just in production?
In production, even it's a private blockchain.
In a private blockchain?
It's the software itself that still has many issues, whether it's public or private.
Well, yeah, private blockchains, we have some customers who are reasonably close to having something that we could say, works. Maybe not in production, but maybe a good pilot with some actually participating members. So close enough, I would say, for private. Again, with quite a few, depends on how blockchainy you want to be, right? It's not super blockchain because blockchain with 5 members is it's a blockchain with 5 members, but still it's a first wave of experimentation, so it's getting there at least. Now, if you are looking at actual public blockchain deployments from enterprise customers, that's going to be a few years from now. Although a few banks have done some trials. But right now, lots of the banks are active in the R3 consortium, where they're basically building this private blockchain between themselves. And EEA doesn't have that approach right now, but maybe that's what will happen. So, and R3, again, some of these guys are pretty advanced, in terms of trade finance scenarios. They're fairly close, I would say, to having something that runs. And again, with a lot of, they probably have the old system running in parallel, right? Just to be sure.
I think there are certain people who should just leave the microphones there.
Yeah. So yes, it will take a while. And I know it's funny that we have this focus on private blockchain, because public blockchain is really super exciting, right? Just that for us, and given our customers, exploring the private space right now makes more sense, of course. The ultimate goal of all this stuff is to help these guys move to the public blockchain. That would be the real winner, right? But it's going to take a while, yes.
So it's a pure opinion question here. No. For any of the EEA, how long do you think before one of those members are willing to bet their business?
How long, sorry, what?
How long do you think it will be before anyone is willing to actually bet their business?
Oh, bet their business, wow.
When it's actually part of their revenue models. If it doesn't work, they don't make their quarterly numbers.
No, so a lot of these moves are still, I think, fairly defensive, right? They want to understand this technology because, it's a threat, okay? That's the basis thing. But again, look at trade finance. They actually, so it's funny because they could probably solve the problem without blockchain, right? But the blockchain is this kind of catalyzer or, this nudge that push them to, hey, we should really look at this now. Let's talk at least a little bit so that we can optimize the processes. So it's funny, probably they could have done that a long time ago without blockchain, but the blockchain kind of moved that forward. So, betting their business is maybe a big word, but optimizing their processes and actually doing business, some business on top of the blockchain, I would say hopefully. Yeah, hopefully maybe next year. No, I think, it really depends. But some business, right, so a little piece of business with actual money running on the blockchain, hopefully next year, I think we will see some real stuff, I hope. I think I also said that last year, but one can hope, yeah. But realistically, so a major part of their business, many years.
You showed some interesting concept about this signing vault, which is an isolated space that's not easy to hack, right? So it's not easy to get access to the private key.
Yes.
But the question I'm asking myself, if that thing is signing whatever a secondary system is presenting to it, it doesn't have any way to verify that what it is signing is actually the thing that it wants to sign. So the security now is simply offloaded to the secondary system, where, for example, a user sees a transaction, he wants to confirm it, and it's actually intercepted by malware where the destination address is changed. So devices like the Trezor or Ledger, they rely on external visual interface where the person doing a check directly interfaces with the secure device. So what's the story here? Can we be sure that such a signing device is actually signing the thing that the user intended to be signed?
So the idea is that in order to call the signing device to sign something, you have to yourself present some credentials that you got through. So you get to a website, you authenticate, you get identified into what for us it's Active Directory. So that identifies you, so you get an ID basically, and this ID is allowed or not allowed to make calls to the HSM. Okay, so you must have been authorized for a specific key for a certain operation. So for that key you can do a get, not you won't, but for that key, let's say you, user, are allowed to do a sign, call. So so you basically have to go through the authentication process in order to be able to make the calls to the HSM. So that's part of the Azure.
Well, but that doesn't help
so,
to really know that what I am signing here.
So what? No. No, it can know who it comes from. And it knows that this key is authorized to this end user. After that, so if the client software maybe is, so the guy would still have to give give access to the fake software to give it his credentials. So hopefully we have ways to avoid that, but that's phishing and stuff.